first year student of CTU. My my project title is Application of Microbit Sensors and Actuators. I choose case 1 as my project. My project has 5 parts. The first part is synopsis. In the synopsis part, my project is aimed to design an electronic system with special specifications as follows. When the button A of microbit is pressed, the output color of RGB LED will change in the screens of red, blue, green, magenta, yellow, and red. And then when button B is pressed, the LED will change in the reverse order. And when the LED is changing, it keeps blinking every 0.5 seconds. The LED brightness can also be controlled by the 10k ohm variable resistor. And the last part of synopsis is my new features. The OLED can display the distance from ultrasonic distance sensor and obstacle. And here it comes to the hardware architecture part. Here are my hardware list. There are breadboard, microbit, H connector, OLED, red RGB LED, variable resistor, ultrasonic distance, and all kinds of wires and pins. For the connection of the hardware, we just connect microbit to H color and connect microbit and computer by the micro USB wire. Then we connect RGB LED and microbit. For each color of wire, the blue wire is connected to pin 3, the green wire is connected to pin 1, and the red wire is connected to pin 2. The positive node, which is white wire, is connected to pin 3 volt. The connection of ultrasonic distance sensor and computer is connected by a USB 5 volt supply wire. And then the microbit, the connection of microbit and ultrasonic distance sensor is the trigger pin to pin 8 and the echo pin to pin 9. The connection of pin 3 volt of microbit to the 5 volt power bar on the breadboard, and pin 0 volt to the 0 volt ground bar on the breadboard by dopant wires. Connect the purple wire of 10k ohm variable resistors to pin 10 of microbit, and black wire to 5 volt power bar on the breadboard, and white wire to the 0 volt ground bar. For the OLED connection, the SCL pin is connected to pin 19 of microbit, and SDA pin is connected to pin 20. And the VCC pin of OLED is connected to the 5 volt power bar on the breadboard, and ground pin is connected to 0 volt ground bar on breadboard. Here are some introduction of microbit. And we can see on microbit there are many sensors, such as 2 programmable buttons, and light and temperature sensors, digital compass, touch sensor or microphones. There will also be some actuators like 5.5 programmable LED screen and the speaker. The microbit is powered by USB 5 volt. The working principle of RGB LED is red color to red wire, blue color to blue wire, green color to green wire, and positive node is white wire. The current flows from the positive node to the three color wire. The working principles of variable resistors can be present as this formula. So we can see the voltage between LED and the resistance between pin A and pin B is linear, so that we can when we rotated the variable resistor, the resistance between A and B will change, and the voltage between the LED will change, and the brightness will change. For the ultrasonic distance sensor, when the pin trigger is digital wrote to 0, an ultrasonic will be triggered. Then, when the ultrasonic meets an obstacle, it will reflect. The sensor will detect the echo and record the time interval between triggering the ultrasonic and receive the echo. Because sound travels at a constant speed through the air, the distance between the sensor and the obstacle can be presented as distance equals to time interval times the velocity of sound divided by 2. For the OLED, it is for display text, graphic, and numbers. Part 3 is software architecture. Here are my code. This part is represent red color. Red color turns on red color. This part is turns on blue color, and so on. And before turning on next color, there is a pause 500 milliseconds to get an effect of blinking by each 0.5 seconds, and then after the pause, there should be a digital write the pin. The pin which is on last color, and it should be closed in the next color. And for the middle part is the case when button B is pressed, and is just the reverse of when button A is pressed. In the forever loop, the first part of forever loop is trigger and receive ultrasonic. The second part is display text and numbers on OLED. And part 4, experimental results. And here I will show you some results of my experiments. When I rotate the variable resistance to far left, and I push button A, a very light color. For the conclusions, the application of microbit sensors and actuators has opened up endless possibilities, from creating innovative wearable devices to automation systems and various fields. The microbit platform enables easy coding for the learners, while sensors and actuators enable efficient data collection, processing, and response. The potential of microbit sensors and actuators is endless, and we can expect them to continue being a forefront of technical achievements. That's all for my presentation. Thanks for listening.